What's going on, everybody? Welcome to STL Sunday, 3D Printing Sunday. All of the names for the same show, different day. So I'm just trying to get some stuff set up on my monitors above me. There we go. Anyway, today I have some odds and ends and things to get done. I brought back STL Sunday because it has been productive time for me. So regardless if the show wasn't super busy, at least I was able to get some things done. But I also wanted to show you guys what the finished product was from last week. Last week, if you guys were here, we were working on a engine. So switching over back to Fusion real quick. Well, this was the file that we ended up with, the final. Now, I did a lot of simplifying to this file. I cleaned it up and made it as simple as possible. I removed a lot of the little fake bolts that were on it so that I could add real scale hardware so that I could attach it. I turned it into several pieces. You know, the intake manifold, the valve covers, the head and block I kind of combined. And then I was going to do the dual airbox thing. I ended up abandoning that. And I ended up going with a stubby servo in the steering servo spot. So I ended up making kind of a fake airbox on top. So that is what we've got there. Radiator, I ended up attaching down at the bottom. And then I also created the bottom half and an oil pan that kind of sandwiches between everything and just gives me the look of that motor from the bottom. So that was the finish of the design, and I've got it printed. So everything except the filter that will go in the little airbox setup. Now, some of this is just, well, the whole top part is just, everything actually is just resting up there. But let me see if I can tilt it without it all falling out. So you can see now it's kind of crooked, but that's just because, like I said, it's all just sitting in there. Went with an orange block. The intake is black, but you can also see the lower half of the block down there and the oil pan. I don't know why it's not focusing, but it's a very convincing look through there. And that whole upper intake worked out pretty well. I separated the throttle body, the intake tubing and hose itself. Oh, I think I must have spot focus on. I do. That's what's going on. Hold, please. Cancel focus. Oh, that's what's going on. Sorry. I have a Ford touching. It's done this before to me. There we go. That will fix it. So now I should be able to show you. But yeah, you see I kind of did like a corrugated design on that. And it sits. Now we be able to see the engine a little better. Again, apologize for the resting nature of it right now. It'll all get attached, but I've got more to discuss on that still. That will sit properly, yada, yada, yada. Anyway, I think the lower half of the engine is what is really going to sell this. It's going to look real good. And it's an orange block. I was able to get the orange in there. So I was really happy with how that came out. Now today what we are going to work on is, you can see I've actually cut the carbon fiber for the firewall. That's done and in there. It's, well, you know, for the time being, that piece is final. But Going over to Fusion. In here now, you can see that these pieces are all windowed out. I decided to go in and window them, kind of, adding all of that, because I felt like with the engine in there, all of this just flat, dead space looked really, really odd. So I decided to have these done out of metal. I had a set cut out of aluminum, and I had a set cut out of titanium. I sent those off to Send Cut Send. They won't be here right away though. So I did them there, and I also did the inner fenders. But what I want to do is I want to do a mesh, like a kind of a mesh so that you can see through there. Now I have a mesh here, and it's from a splatter guard for cooking, like cooking bacon. It's just like a wire mesh. But I'm going to add that behind there. But I do have another plan that I want to execute with that, and that is stamping it so that it pops up into these cutouts a little bit. It's a little over the top, totally unneeded, but why not? So that's one thing I want to accomplish. And the other thing is I need some mounts for the interior to hold the interior down in the appropriate places. So I've got to get that done as well. Those are my two tasks. Today I said I had odds and ends. Those are them. But the first thing that I want to do is kind of go through the process that I go through to create a mold. And, whether it is for the forged carbon stuff or for the pressed metal, like if you haven't seen the pressed metal stuff that I had done before, create a 2-piece mold that's just 3D printed. You put some thin aluminum between them, put the molds over, and you just hit it with a hammer a bunch. And I've done it with a vise as well, but honestly, the hammer works much better. And you can get really cool designs of parts done with stamped metal. So this one I'm going to do the same type of thing, but just with some mesh. I hope that it will do it. I'm probably going to do this top part first, and we're going to see if it works. Okay, thanks everybody for joining in. Yeah, so I'm going to go through this. I am going to, let's see, which file should we, how many, does this one have? This one has a ton of sketches, I believe. It does. So we are going to, actually, let's just do a new file for this one. And I'm going to call, we have to save it first because I have to bring some files in. So we're going to call this Commando Mesh Stamps. So once that's saved, we can then go Insert Derive, so we can pull in some items from our other, where's my Nationals projects, and we can go to the structured bolted file. That mesh is stainless. It will need more force to conform to the shape you want. Yeah, I think that's why I kind of assume that it will ruin the stamps. I assume that it will, being so hard and stainless like that, I assume that it's going to take a lot of force. I may over exaggerate the mold so that it tries to force it more, and then it kind of settles back to where it needs to be. Again, it's going to be a complete experiment, which is how a lot of it goes. Do you think forged carbon would work for a bumper? It could. It seems like a poor material choice just for the area, but I mean, it could. So I'm going to grab all of these things, but I'm also going to grab some of the 3D printed parts that connect it all, just so that I know where everything is. I think that is all I need. Might as well grab the firewall too. And we'll hit OK. Would heat help the stamping? Possibly if I wasn't using 3D printed molds. Since I'm using 3D printed molds, heat would probably just cause a lot of issue. We are dropping some frames currently. I apologize. So here is the parts that we're looking for. The lagging should be done by now. Now, I don't know how much definition we'll get, specifically in areas that are so tight like this. But we're gonna deal with it. So I'm going to, something like this, a lot of times these molds I just kind of have to work in little chunks and make progress because I don't necessarily know what my end goal is yet, but we're going to go with it. So I'm just going to extrude a shape through that pocket, make sure that it's a new body. So I just projected that other outer geometry, dropped that down. So this will have to become the bottom piece. So now we can actually just isolate that. So that'll become the bottom piece. I really should leave a little bit of, how about aluminum foil in the mold to help the heat from I don't know that that would work, especially with the force. You got to put a lot of force on these things. I doubt that it would give enough protection. Aluminum is such a good translator of heat that I don't see it working. And for something as simple as this project, let's see. Just want to see if we can, oops. Let's do a quick inspect. What is my height here? I need more. Oops. It's still just 1.58 exactly. Okay. So let's see if we can do a chamfer of 1.58. We can. Look at us go. So that could basically be the inside of my mold. Now, I don't expect that I'll be able to get enough definition out of it. So is the aluminum mesh? No, there's not. The mesh that I'm going to use is this stainless mesh. That's what it's going to be. Even if it's only flat behind it in the end, it's still going to be this mesh because this mesh looks great, and that's just what's available. So with things like this, we're going to, in the end, we're just looking for a little bit of extra definition. So let's go with a 10 millimeter flange around the outside. We'll just add like 4 millimeters down. So a super simple base to this thing. Now let's see. So there is an offset face thing that we can do. So let's try. I've never actually done it with this process before. So I'm going to project that. We're going to select the whole thing and we're going to drag that up like 7 millimeters. We're going to make it a new body. Hit OK. And then I'm going to do a cut. So I'm going to use the combine tool up top. We're going to change it to a cut. Target body is going to be our top. And the bottom is going to be the tool. And then we're going to hit keep tools. And then hit OK. So we can turn off the bottom of that mold now. And the top will have the negative of our cut. Would the mold be brittle if frozen? Probably. There's no reason to take extra steps. It's a 3D printed mold. It's just going to be 3D printed. It is what it is. Like, you're not going to substantially change it. You're going to go through a ton of extra work for something that's 3D printed. It's really just not a thing that's worth. We're just going to plow through what it does. We're going to see exactly what, if you're going to try and do anything, you're going to end up doing like, transferring it to a different material by doing plaster molds. But again, it's not worth it with this type of thing. This is just a very basic project. So I'm going to, since I initially made this based off of a super tight dimension to the actual hole, we're going to see about offsetting this inwards by like a millimeter. It won't do it. I kind of figured that it might be the case. There's always a little. Can I do? I do negative 0.5. Actually, press pull won't work on it anyway. So basically, what we need to do is just we're trying to. I'm going to try something different. Can I do that same offset face? We're going to try something I have not tried before. Can you just print the mesh? No, you can't. It wouldn't look good. It would look, for one, 3D printing doesn't look that great in areas, and a 3D printed mesh in general would just not be. I don't know why you guys are so hung up on that. it's just a mesh. Like, this is going to work fine regardless. Even if it's flat, it's going to look better than anything else. So stop getting so hung up on very simple details of this. Okay, so I'm going to try an offset face of this now. Okay. All right, and then we're going to go negative, or sorry, not negative. That's going to be positive. Let's just go with, it's just not going to do a millimeter. It won't do any of them. Okay, we're going to, let's see. We're going to try this one more time. We're going to do it without the bot. Sometimes CAD, it does not work in the same way for every project. You got to sometimes just fiddle your way through it. It's just the way CAD goes. Even if you know what you're doing, sometimes it will make you feel like you don't the others. Okay, so that let us do a 0.5 millimeter offset that direction. So we're going to be okay with that. We're going to do, now we can just do a press pull on this one by a 0.5 millimeter. Sure can't, because it won't let us. See, even very simple things. Dang it. So we'll just do it the easy way, or we're just gonna do a offset like that. Extrude everywhere here by 0.5. Make sure that it's a join, not a cut. So now you can see that this is much shallower than that. We're not going to use this piece. I'm going to use that piece as a tool. So we are going to go back to the bottom. Oops. bottom. And I'm going to move that back over. How far did I go? 67 millimeters. Okay. We're going to turn off the one that's go. That's why, because I moved the wrong one. Okay, so that's fine. I've got the shallower one here. Going to move it 67 millimeters. Okay, and that was body 10. Is your offset to allow for the thickness of the material being pressed? Yes, that is what we're doing. Now, the reason that I did all of that was so that I'm going to use this one as a tool. That's when we just offset a little bit. So we're just going to do a cut. We're going to grab the top one, bottom one as a tool. I don't need to keep the tool this time, so we're just going to hit OK. And now I can have, let's see what we've got remaining. I think I did that backwards or something. Why? No, it did it. Okay. So I felt like it kept the tool for some reason, or it seems like it did. We'll figure it out. We'll figure it out. Let's do a quick inspect and we'll do a section analysis, which is, why am I not seeing it? There it is. So we are leaving that gap there, as you can see, as we, my arrow's in a inopportune location, but you can see as it goes, it leaves that gap, which is consistent across the actual shape. So now you can see there's no area out here. That's fine though, because this is all just going to get smushed together. And I'm just leaving some room there. So you only need the room in the middle. But that is really, that's going to be my entire experiment for this, is just to see. This is just going to be PLA. It's going to be a very simple thing to see. We can turn everything else back on. So that is just that one piece. What I probably should have done was combine that same part with the other one, the other cutout right next to it. Probably would have been a smart idea. You know, there's things that I do that I wonder about every day. So I could just go back and start kind of, I'd have to start turning all that stuff back off again. What did I have? 1.58. So I'll go through and continue to get those things. How about flashing or mounting? What do you, I mean, the flashing on the outside will just be there. It'll get trimmed by hand, and then mounting, it's going to be underneath of a metal panel in some areas that are almost visible. This is going to be stuff that's mainly attached with some sort of adhesive, either an epoxy or the shoe goo type thing. They're going to be like the inside of this one, you're not going to see at all. So it's a simple one, but there isn't going to be any fastener mounting unless it gets sandwiched behind something, but that's not the plan. So, did you take into account the mesh will sit outside the tool as well, so it doesn't need to be deeper? What? The mesh can just be cut. around. It'll be a general rough shape. Doesn't matter if it sits outside or anything like that. So that is basically how that stuff gets handled. All that with only 46 days to go. I agree. But the good, I mean, part of it is that these panels that I had done, like this, like I won't have those right away. If I had these already, I wouldn't even be thinking about doing extra things to it. And I would just be already moving forward. The class 1 yesterday, I cut off the front bumper, or cut off the front of the chassis rails, so that it's ready for the front bumper to get built. The front bumper tabs are being cut at Send Cut Send right now as well. So there's only certain things that I could get done as far as how that went. A lot of the other stuff though, I'll start being able to get the back half of this reassembled today, because I cut some of the other carbon fiber pieces. I finished the cage welding, put the rear bumper on it. I need to do the mold for the rear half of this body though, which is a whole nother thing. He's only got 41 days worth of printing left to do for molds and stamps. That is, Brett, did you release new brake rotors that are very thin? If so, I need 4. Those looked good. If not, I'm going to have to make my own out of carbon, which I'm not opposed to. But if you're already releasing them, then I would like to buy 4. So there we go. That is basically how that will end up. Now you got to, he is saying that the mesh molds will come in complete extra space between the molds. Yeah, I know what you're saying by, like how it's not, you need to leave some room. Otherwise you end up just, wailing on the corners only. And that's not the intention. So you need to leave the space. You need to leave space. That is a thing. I know that there's not space shown for the other, because of the thickness of the material. But if you don't leave the space for them when it's closed, you don't get a good looking mold. It hits only high points and it deforms more than anything, and it doesn't work out right. I've been through this before with aluminum. You basically, if you don't do it this way, you don't end up with anything that looks like the defined shape you were going for. So I encourage you all to try your own style, but this is something that has worked well with the aluminum so far. If it doesn't work with a more difficult to work with stainless mesh, I won't be surprised. But that's, like I said at the beginning, this is all for a experiment for sure. Okay, so that's kind of the path that I'm going through. I think that I'll come back and work on this maybe here in a little bit, but the interior mounting, mainly, yeah, the interior mounting is something that I definitely need to do more of, mainly because if I'll work on that instead of stamps, because all of your stamp suggestions are driving me nuts. I'm kidding. I've been through this whole stamping thing. I had a lot of error in the first ones. This is the style that works. Okay. Now, the interior. I need to go to the one that has, the file that has both of my interior parts. Is Nicole going to get mad because you took her strainer? This was specifically purchased because of the very nice, fine stainless mesh that it has. It's very good looking, and it was available on Amazon. So I've got this wire mesh thing with like some holes cut out of it already. Like it's sometimes I sometimes I even wonder like, man, why do I buy these things? Or if someone walked in and like, why do you have a splatter guard that's got holes in it? That doesn't seem like that would work. Okay, where is my... There's rear wells. This is the file that I think... We're just asking for knowledge. I know, I was kidding. If you were actually all driving me nuts, I would tell you. So, this here is the file that I have that I created my rear inner fender wells with, and I've got the interior mold from the first part of the base. These were molds that I designed for, what's that process called? Why can't I think of it? Heat, not heat shrinking. I can't think. Oh my God. Okay. You guys will know what I'm talking about. The vacuum forming. Thank you, Phoenix. Jesus. Obviously, it's too early. God, how can I not remember vacuum forming? Jesus. So, but the problem is that with vacuum forming or anything, especially at my level, what I'm doing is not, you know, it's fun and cool for a one-off build, but it's not the, you know, I'm doing 3D printed molds with some plaster in the back. Like, it's rough. Like, yes, it's more than you would normally do, but it's still a very rough prototype. So things don't like sit perfectly everywhere. I need to turn off some... My mouse is being hyper funny these days. I think I need to put a mouse pad back in here. Oh, it's there. So I need to create a mounting point that will snag this corner of the interior, attach to the bottom, and attach the attach to that panel, just so that I can get everything like locked together in one place. I've got an extra, you can see that I selected the, call it the floorboard on the passenger side here. And I've got these, I put extra holes in those corners. They don't attach to anything. They just kind of float. They're outside of the back. But I did that just so that I could have possibilities for things like this. And it turns out that it's not in a terrible spot for what I was after. So that's going to serve that purpose. It should be a very simple part because this is just, again, it's fancy connect the dots. Like I know where I've got a hole and I know where I've got two surfaces that I want to capture. So I just need to make that happen. I'm going to do a sketch. We're going to start on that base plane. Now, another thing to note is that this surface here, this blue, that was the 3D printed mold surface. So the plastic sits to the outside of that by 0.75 millimeters, because that's the thickness of, you know, the material that I'm using. Now, granted, it's probably a little bit thinner because of how vacuum forming works. It stretches material a little bit, but it's just, you know, a part of it. Josh, so when you're working at Vanquish, is designing stuff this way part of what you do there? Not as much. I don't really design all that much at work. So I get to be, I'm part of design meetings and I do some design, but I don't really sit at CAD at work all day that much. I've got other things that I end up doing, and I also do programming a little bit now, so for machines. So, and Swiss machine programming is a little different. Anyway, we are going to like I said, I need to know where the outside of this is. So I've got the outside of the mold. We'll offset that slightly. Did it give me 2 lines? It did. It's okay. Go to the top just to see. So it is that outside one, and that's the one that we're going to have to offset. Delete the other one. We'll worry about that back portion later. And then I'm going to snag the front surface of this as well. There we go. A little bit going on there. Now we're going to just turn off that tunnel because it's in the way. So we know we have a spot out here. Let's go a 2.5 millimeter hole. So I have a threaded hole. 2.5 millimeters is what I like to use for threads into 3D printed plastic. It's the minor OD of a 3 millimeter screw. So it gives you enough bite, doesn't give you too much resistance. If you have too much resistance on a 3D print, it will basically just rip the plastic out and then you're gone. So we're gonna go with about an 8 millimeter OD. Like we said, this is the outside of that. So we're gonna move that out by, that's a path. That's okay. I'm going to deselect that. We're going to remove chain selection. There we go. I'm going to flip the direction. And rather than going the full negative 0.75, I'm going to go like negative 0.5. So maybe make your green base a rectangle instead of an angle at each end. I don't know what you mean. You're talking about this thing? That thing is already done and welded to the cage. So that is already, we're past that. And this has to go in later. This piece has to go in underneath of the interior. So for assembly reasons, that wouldn't work either. So we're gonna go negative 0.5 again, just because. And we do need to, let's extend. I'm telling you, this mouse, something about it is being funny today. Okay, so extended until those met each other. Now it did lose reference to the dimension, it appears. Sometimes when you extend, it does those things. Okay. Now we know that we have to come back to this area a little bit. We're probably going to do a cut with that body just to make sure that it's in the right area. Which that is fine. Now let's do an offset on these about like that. We'll just go 5 millimeters. I'm going to close that up for now. And it's just undefined, so we're going to put a dimension on that. Same here for now, just because I like the sketches to be defined. We need to connect about like that for now. We'll just do a couple of tangent constraints. That's weird. Okay. So just getting something started. Make sure we get the inner side of this, and it wants to make it difficult to select that. We're just gonna drag this thing up like 8 mil. 6. We'll go. 6 will be fine to start. New body. Are you going to carpet the floor? I don't think so. We're flocking the seats, but I think that's about where we're gonna. I think I'll probably just spray some sort of texture to make it work. Now I just did a shape so that I could see what this thing was going to be like. Of course, I need to make this fit more to, this one is going to be fine here because that's just a vertical face. The other one, though, not so much. So we are going to have to do a cut there. Flock the floors. Flock them. Flock it all. So I'm just going to create a cut to make sure that this fits. And do the same 0.5. I'm going to just project the whole thing. Actually, that's I can't do it just an offset that direction. That's okay. So we're just gonna, I'm just gonna start at that bottom, and we're just gonna do a parallel line to that face and cut to the edge of it. We're going to make sure that it's only cutting, not cutting the tunnel. Hit OK. Scale right. Yeah, like I'm thinking just something like this. I had made a kind of a jokey post the other day about like, should I flock it or flex seal? But flex seal is an actual option, but I was just checking the radius on that. It's a 2mm radius, so we're going to throw that on that. So we're looking about right. Yeah, I'll just put some sort of texture. Now I'm going to have carbon fiber floors, so the tunnel will be the only thing that has that. Well, the tunnel and these rear wheel wells. Let's see. So we got that. And what else do we need? We need to, of course, we need a mounting position at the back here. So that is one thing that I don't like, is I only have one hole that's going to be mounting all of this. It's just an interior, though. I probably shouldn't worry so much, but I would have liked to have had two, but I'm not going to add anything different. This will be an 18-pound class one. I don't think so. Everything is carbon fiber, very thin Lexan, or titanium, which is lighter than a regular roll cage. Like, I think you don't understand the materials that are being used, Brian. If for as much as will be in this thing, I think this will be one of the lighter trucks that is anywhere near this. I think like these rock sliders are the, only thing that's like, I look back and I'm like, oh, I should have done those out of aluminum or something now, being that I went so far into weight savings. Like, I don't think this truck will weigh anything more than what I'm used to driving, just with everything that I've done so far to keep weight out of it. Okay. I guess I'll be able to install the screw through the inner fender. Yes. So I've got one of the, switching here. This is my Lexan inner fender. And this part right in here is what will come down and match against that surface. So I'll have access through the inside. A single screw, I guess, will probably do it just fine. Just trying to think through the little hurdles that I have. Shelf Queen Afterlife. The only reason anything turns into a shelf queen here is I just don't drive it. But it's not because I'm trying to preserve them. I beat the hell out of my Ripper once a year at Axial Fest. So I'm just extending that so I can make a cut. Taking a look at my interior tunnel to see where I cut it, and I made the cut on that at this surface. So this drop down does not exist. Does not exist on the actual Lexan piece. So again, we're just going to do a cut, and I'm just going to grab. This mouse is highly pissing me off today. So can I extend a projected line? That I do not know. Negative. Did not think so. Okay. So extended that. We'll cut through it. Again, make sure that we're not cutting anything but. There we go. So now we've got that piece. I'm going to isolate that body, I think. Isolate. Now we need to add a screw hole on this somewhere, 2.5. Let's make it at least at least 8. Now we'll go over this way. I'm not usually this jerky with the mouse, but like I said, something's going on with it today. I don't want it to stick out much further than this one, so let's just project that line, and then I can make those two lines collinear. That way everything will line up properly. There we go. Gives us a baseline. I'm going to put that and that I need a coincident between that and that. I like that positioning. And now we'll just extrude all of that back. 7 millimeters, sure. It's an ugly piece though, so let's do some cleanup. Let's just extrude back to there to cut that. Let's do a sketch down here to make this look better. Whoa. Guess I gotta close that up. Well, there we go. Get that cleaned up a little bit. And now I don't like, let's see, well, let me do, I don't like when it carries that. We'll do 2 millimeter there. What is the best threaded insert? So I've got some of like the brass threaded inserts and things like that. I don't use them a lot. I've tried the heat set ones. I've got some of those. Again, I just don't find myself using them that often. I don't know. I really haven't found one that I love out of all of them. Even I guess it's specifically with 3 millimeter. I don't have 3 millimeter inserts that I've really enjoyed. So let's do a little. I still want to do a little bit of a my God. I'm telling you, this mouse today is trying to make me mad. So, we got that. Let's throw a very tiny chamfer on the start of our holes just to allow it a little bit easier for the screw to start. We haven't added the actual mounting holes for the the tunnel interior though. We've got areas. I don't know that I want one in the front because it could be. Actually, I can mount this piece to the tunnel before it goes in. So let's do one up there. Let's 2.5 and 6. Now let's just define these locations quickly. 6 and I went down that far. Yeah, I do. So we're gonna have to use this sketch a couple of times, but we're gonna go -6 as a join. And we're gonna need to open that sketch back up and do that as a cut. But I'm also going to use it again as an extrude just to make things nice and even. Oops. Going too fast, doing too much. Join. How did that end up in there? Well, that's interesting. We're just gonna see if we can select all those faces and hit delete. Hey, look at that. Rather than actually fixing what I probably messed up, we're just gonna delete faces to make it smooth. Smooth operator. Some fillets there. We could doesn't want to let us fillet that. Tell you what we're gonna do. It's at a weird angle. We've got this kind of nasty corner here that it's interacting with, but I'm not going to be able to get it far enough away anyway. So we're just going to see what it'll allow. About a 0.45, a little bit of one. There we go. Okay, so that gives me one there, one there. I'm going to put one more over here, and we're going to call this piece pretty much completed, because that's really all I needed for an interior mount was a pretty simple item. What did I do off the bottom? 6 millimeters? I think so. And we'll just call this. What do we want to do? Let's do 15. Make sure it doesn't, yep, not going to interfere with that one. We're going to go, oops. Turning sketch back on so we can use it again. And a third time. Probably should have just done it on the first one, but it's fine. Okay. A few little things there. I'll add another couple of chamfers just to make things smoother. Same thing with there. Let's try that. Well, let me do a, might even let me do a regular one. It did let me do a 1 mil chamfer. What do you know? Bonus. Okay, so that should print pretty well. This is a very simple piece. Again, this was all about just connecting dots to get this thing to allow me to screw the interior in here, here, and then one through what will be that back, that inner fender, that, you know, vacuum formed inner fender. So you can tell I got pretty close to the top there, but still a safe distance. I'll mirror that onto the other side, so we'll have interior mounts on both sides. I don't have anything up front, but the shifter notch really kind of holds it down, which is going to probably work just fine. Just having the 4 mounting points now back there is going to do it. Looks like that's all I needed. Something simple. A simple design to hold a pound of screws. Need some aluminum hardware. You know what? Aluminum hardware I could do, because when I did, when I put the carbon fiber firewall in, I actually used titanium hardware for here. Because I still have a bunch of titanium hardware that I bought for the TRX6 project. But aluminum hardware is something I could get into. I could buy a bunch of that for stuff like this. I should look for a good source for aluminum hardware. You guys buying any of that? I haven't bought aluminum hardware since the comp crawling days. So, yes. Let's see. We've got that. My big project for today, beyond finishing the molds for the front stamps, printing those, and then hopefully testing those, is that I need to design the mold, the forged carbon molds for the rear section of this body. And that is not a small task. It's going to be, I think that I'm going to break it up into separate cab corners, a small roll pan area, another cab corner, and then the tailgate separately as well. So I think that will be aluminum combines with carbon equals corrosion like heck. True, but in some of these instances, I won't be in carbon. Like that area is only 3D printing and what's the other thing? Plastic vacuum forming material, PETG. So PETG times dose. So I've got those to do on both sides. And this thing, designing these molds is like an absolute, I just sit here and I bang my head and I try and figure out what the mold is like over and over and over. Whew. My 13-year-old daughter watched for the first time Friday night. She loved it. Thanks for that. That's something we can do together. Hey, that's awesome. I'm glad she did. Hopefully it wasn't inappropriate. The other thing that I am thinking of is I am thinking of doing forged carbon sides. I was not considering that before. I was just going to do CNC cut carbon twill like my firewall here, but I don't know. You should do the letter in the tailgate in titanium. Whew. I mean, I did send the grill to be cut out of titanium. Because, you know, maybe, it's like, maybe that'll be fun. So, I mean, I could. It's a possibility. I'd have to attach it somehow. I may do the whole tailgate out of stamped aluminum, just because I really like the stamping, and I haven't done anything like that on this one yet. And the contrast of aluminum, and I don't know yet. We'll see. Honestly, the other projects that I have, we've really been kind of, I think it needs forged sides. Man, Brett, I know. I just don't. There's a few reasons why I'm thinking about doing it. One, the look of consistency. Two, I could add some features that I could use. It could be really helpful. I don't know yet. It's a lot of work, and it does. Oof, it does. I don't know. I don't know. I'm torn right now, but I'm torn on a lot of things. Like I said, the rest of the things that I have are actually pretty in depth, and I'm gonna have to get into. It's gonna be a lot of staring and scratching my head, so probably not fantastic for STL Sunday. I can show you this project, which was my This is the rear steer axle for my class 3, class 2, class 3. I'm using my brazen scale class 2 and converting it to class 3. But I needed a rear steer axle, and I needed it to be 4-link because I'm not going to do a chassis mounted servo. I don't want an aluminum axle back there if I'm not running aluminum in the front. So I needed a solution. So I took a stock F10 centered rear, and I took the ends of a front axle that I cut off. I did all that in CAD as well. And I made these little washer pieces back there to help as I designed a truss that will then hold the servo. And that was a fun little project. That is this. And it worked out really well. It still has the brass tubes in there. I machined them down to length on my lathe, put those in there. And the last, I need to fabricate the axle shafts, which I did in a specific way that has made it easy for me. So once I get that done, I'll pull the tubes back out, and then I'm going to use some epoxy, get them all going. Any chance of getting those files? No. No. But the tubes actually sit in there really, really snug. So machine to length. But could you please show quickly how to make this air hose? Can't figure it out. Sure. That's an easy little fun. I mean, it doesn't have to be exactly how I did here, but that little like corrugated look like that. Let's do it. I'll show you. I'm not on the right screen. This one here, how it's got kind of, so that actually bends. See, it's got an upward bend, it goes straight, then it bends again. So you can see. So yes, let's do one from scratch real quick. So let's do I'm not going to do this to any specific dimensions, but we'll do one basically that same style. So we'll go up 10 millimeters at 20 degrees. And then we'll go straight for 15 millimeters. And then we're going to turn on 3D Sketch over here on the right. See that last little dialog box? And when we select that line, we're going to, so that little thing pops up because we're in 3D Sketch. And then I'm going to take And we're going to grab this one over here and I'm going to rotate that 90 degrees. And then I'm going to just go over 10 millimeters. So now we have this 3D sketch that goes and follows that. We're going to throw fillets on there. Hit F for fillet. Oh, wrong fillet. It doesn't work in Sketch, sorry. Select those two, and let's do like a 10 millimeter. Let's do a 15 millimeter fillet there. Let's do a 10 millimeter here. Let's do 8 millimeter fillet there. Okay, so we're gonna hit finish. So that's gonna be the direction of our air intake. You could do it straight, you could do whatever. I'm just adding some curves and stuff like I did. So then we're gonna go down to pipe and we're going to select that. And let's make this a 10 millimeter air inlet, which is pretty much what I had. This is very similar in design to everything that I did. So we'll hit OK. So now we have that part of it. For that corrugated look, I'm going to take and I'm going to select the end of this to make a sketch. We're going to do a circle, oops, based on the center. I'm going to turn the 3D sketch back off. So we're just going to go, that was a 10 millimeter pipe. We're going to make this 12. So a little bit larger, right? I'm going to hit extrude on that top part and we're going to go 1 millimeter. Actually, let's go negative 1.5. So it's like that. This is going to be a new body though, not a sketch. So new body. And we're going to hit OK. And now I'm going to, before we do anything, I'm going to put a radius on this of 0.75. So kind of gives us the ribbed look that we're going for. I'm going to go, I'm going to go 11.5 on this. Make it fit a little bit better there. So now one thing I'm going to do is I'm going to go back to the sketches and I'm going to turn on that first sketch because we need that. So now to get that look, we go down to pattern and then we go to pattern on path. We're going to select bodies, which is that new body that we made. Path is going to be that sketch we just turned back on. The distant, we're going to turn this to spacing rather than distance. And we're going to make our spacing, let's see. I'm just giving myself a little bit of a visual. Let's go with 3 millimeter spacing. And then let's just turn up our quantity. And you're going to see it's not going to work right yet. So watch. I'm just going to see we're going to crank. I'm just doing this to show you, but you can see how it doesn't look right. What you need to change is the orientation. You don't want identical. You want path direction. See, now it follows it properly. It stays normal to the path, it's called. Normal is like 90 degrees. So, and then we just kind of adjust our instances until they match our needs, which I'd say that's about perfect. We're going to hit OK. We can turn that sketch back off, and then you're basically just going to go through and do a combine. So join, select the main one. Doesn't. We're going to turn off. It's not happy about something there, but that happens. Let's turn that back to join. It's that one. It's not happy about that one little tube. So bizarre. Want to make a limited production run? Built them around the Phoenix, make all the custom designs pay off? No, trust, there's no chance I would want to have the. This thing is so like it is not. It is not worth doing for production. Trust me, this thing is a hodgepodge of custom nightmare. But that is how we made that intercooler, that piping, corrugated piping. Look, of course, you could change the structure to be any style you wanted. Like, rather than that, you go, it's got a different look. Then make it, that kind of looks more like wire looming, you know. So you could do all kinds of, that was extremely informative. Well, there you go. Hopefully that did help. Pattern along path. That's the biggest thing to remember. Pattern along path can be super, and thank you, Gordon, by the way, for the donation. Much appreciated. The pattern along path can be super helpful in a ton of different ways. Like, you just have to figure out when you need it. What is this file? I just had another open file for no reason. Okay. That's how the Ripper started, right? Kind of. But that one was like a design for a one-off. And then basically we went back and redesigned it because it was going to be not a one-off. And it still had to be, there were still certain like things that we did. It was just like, it's low volume, so it's fine. But it basically, we did once and then we redesigned it again. It was definitely something. If you wanted to make this for some reason, more functional, you could also do hollow. Make your section thickness 1. Then you actually have a functional intake to it for no reason. And now I still don't know why I've got. Oh, I had keep tools on. Can I go back and adjust that? Edit, turn that off, hit OK. There we go. Now I still have that one guy, this little guy right there. Don't worry about that little guy. It doesn't like it. There's something wrong with that one. Huh. See? I bet if we went and edited our distance to like 3.1, or maybe it's still mad about something. Nope, it still hates me. That's the dumbest shit ever. I'm just mad about it being stupid. We're going to try it one more time. This is just purely out of curiosity for me, why it hates this. Oh, maybe we did fix it this time. We did. There was just something about that spacing it didn't like. Interference? No, I don't think so, because the interference here, it'll just merge them all together. I don't know if it was something with like that being on top of that bend in that spot, even though we had it crossing over here and up here. Who knows? But try it. That's what we had there. And I just crashed it into an air box. I'm going to print this. I don't think I have any red filament, because I was going to I was going to I might just print it out of orange just to have it in there so I can drop it in and be done. Maybe I even have some paint, but that sounds ridiculous. I can't see me having that. But overall, I'll tell you what, I am very happy with the 3D printed engine. You know, being able to see it, having it clear the axle perfectly. That main pulley is right behind the truss, like it's in the perfect spot. I feel like I needed to 3D print a belt, you know, the drive belt or something like that. But everything just is in pretty much the perfect spot. So that's going to do it for this week's STL Sunday, though, guys. I've got a lot of work to get back to. Thanks for joining. Another good week on numbers. So I appreciate that. Appreciate all you guys for joining. Hit the like button. I've got to go make more coffee. I've got stuff to do. Hope you guys have a good Sunday. And we will see you for scale news, right? Tuesday. Later.